Hello, this is a video presentation on the topic Analog Compute for HAI. Allow me to introduce myself. My name is Ishit Garg and I am a third year BTech CSE student at Bennett University. And this video is a submission for the subject CSET 303 Seminar on Special Topics in Emerging Areas. The faculty for this subject is Dr. Mohammed Abuzar Saeed. With that being said, I'm going to break down this video into three simple sections. Number 1, the introduction. Number 2, the identified problem. And number 3, the solution. That's it. I'm going to keep this simple. I'm going to introduce the topic to you. After that, I'm going to provide you with an identified problem related to this topic. And then I'm going to conclude this video by providing a solution to the existing problem. Let's begin the video by talking about Edge AI. What is Edge AI? Well, Edge AI refers to the implementation of artificial intelligence in an edge computing environment which allows computations to be done close to where data is actually collected, rather than at a centralized cloud computing facility or an offsite data center. In simple words, it is AI where data is present. Edge AI is performed through sensors that collect data and provide it to the AI model for decision. For example, let us consider self-driving cars. A beautiful implementation of Edge AI is through self-driving cars. There are lots of little sensors present on a self-driving car, with the major sensor being the eye of the car, that is, the camera. There is a camera present at the front or the back of a self-driven car that captures the video of the road the car is traveling on. After that, the collected information is processed by the AI model to make decisions based on the car moving in the front or an obstacle on the road. The AI model decides the best route to be taken by the self-driving car. Edge AI also finds use in a lot of other applications, like drones or smart factories. Well, now that we understand what is Edge AI, we need to understand something that is at the heart of an AI model. At its heart, every AI model is driven by a perceptron. The perceptron is a mathematical model that was introduced back in the 1950s. A perceptron is an imitation of the human brain. It receives input and processes it through a set of layers to provide a required output. The layer in between the input and the output contains certain nodes that have some weights assigned to them. Once an input is passed into the perceptron, a calculation is made for a particular bias. The calculated value is then compared to the value of the bias to decide if the neuron would be fired. In terms of computing, a perceptron is simply a layer of large matrix multiplications that have very complex multiplications for large AI models, that is, AI models that are trained on large amounts of data. Let us try to understand the concept of a perceptron with the help of this beautiful graphical illustration. In front of your screen, you have the image of a cat and the image of a dog. As you can see, the image of the cat is being provided as an input to the perceptron. The input information is being passed through a hidden layer. A lot of matrix multiplications are being performed inside this hidden layer. The final result is the output, that is, whether the given image was a cat or a dog. Through an understanding of how the perceptron works, with the help of this GIF, let us talk about how the calculations in the hidden layer are being performed. The calculations for the hidden layer of the perceptron are usually performed through digital compute. Digital compute is the modern form of computation. Simply speaking, digital compute is computation based on zeros and ones, that is, binary computation. Digital compute uses transistors for calculations. It is present in most modern technology, like the laptops or the smartphones that we use every day. These electronic devices seem capable of performing our everyday tasks, but what exactly is the problem with these devices and the modern form of compute in reference to the topic of discussion? Well, the identified problem is this big blue truck. What is this big blue truck? And what does it have to do with edge AI or digital compute? The name of this big blue truck is ALVINN, which stands for an autonomous land vehicle in a neural network. This was the first attempt at a self-driving car all the way back in the 1980s. Let us understand how this self-driving vehicle worked back in the day. You see, ALVINN had a camera at the front which captured the image of the road it was traveling on. Further, a real human driver was used to drive the vehicle around a specified path, and the video captured was used as a guidance for the AI model to decide which route to take for the ALVINN. The images captured by the camera at ALVINN were processed to decide the steering angle of the truck and the direction it was supposed to be headed on. You see, the back of the truck contained several digital computers. All of these computers were given a sole job of performing the large matrix calculations that were required for the ALVINN to be driven in the right direction. It is important to understand that this process was performed through digital compute. And why it is important is because ALVINN drove with the top speed of only 2 kilometers an hour. This is because of the limitation of digital compute. You see, digital compute may be efficient in performing the everyday task we require to do with the help of our smartphone or laptops, but it is inefficient in performing the large complex matrix calculations that are required to train an AI model. This is the reason for the top speed of this first self-driving car. Let us take a look at a possible solution to this problem. A possible solution is the method of analog compute. This is the old form of computation. Analog compute is the method of compute that is based on the properties of current. That is, individual currents traveling down the same path add together, and a current being passed through a resistance is multiplied by the value of the resistance. Analog compute is a very powerful, fast, and efficient method of calculation. It is more efficient and quicker than the modern digital compute. What's special about analog compute is the fact that it is very useful in performing the large, complex matrix multiplications that are required for an AI model that is based on a perceptron. All of these qualities make analog compute a very promising solution to the problem of the limited computation speed for a perceptron-based AI model. However, there are some key challenges to using the method of analog compute. You see, analog compute cannot calculate exact values. Since it is based on the property of current, analog compute can only calculate continuous values. Additionally, the data that is processed through the analog method of computation becomes highly distorted after multiple iterations. Also, it is important to take into account the percentage error that arises due to a given resistance. This is because of the percentage error present in the value of the resistor. The challenges, however, are not just limited to the method of analog compute. Well, the problem is not just limited to the method of analog compute. The digital compute originally used to drive ALVINN is also prone to some major problems. The biggest problem faced by digital compute is the energy consumption. In order to perform the complex matrix multiplications for a perceptron, in the method of digital compute, a dedicated GPU is used to perform the calculations. The graphics processing unit is a very useful method of computation because it allows parallel processing of information and allows the possibility to lapse time while performing calculations. However, the drawback to using a GPU is its energy consumption. It may be insignificant for small amount of data, but in order to train a very large AI model, such as the AI model required by a self-driving car, a GPU needs to consume huge amounts of power. To train a large AI model, the amount of electricity required by the dedicated GPUs is equivalent to the annual energy consumption of 3 average households. That is a lot of energy. Also, it is important to take into account the environmental impact of having huge data centers all across the globe. The data centers that are dedicated to performing the large complex calculations using an array of dedicated GPUs. We are still unable to find a solution to the existing problem. So, what exactly is a promising solution to the existing problem? The solution is actually quite simple because the solution is a combination of analog and digital compute. Let us try to understand how this happens with the help of this given diagram. In front of you, at the top of the screen, you have two matrices that need to be multiplied. At the bottom is the structure of a perceptron. The values from the first matrix can be used as inputs to this perceptron. These inputs are converted from digital to analog values. The analog values thus obtained are then passed on into the structure as individual currents. The values of the second matrix are used as weights for the individual nodes present inside the perceptron. These weights can actually be used as values of the resistances present inside the structure. The oncoming individual current is multiplied with the resistance and is added together at the bottom of the structure. The final result is converted again to digital values, and the values thus obtained is the result of this matrix multiplication. And this is how the proposed solution of using a combination of analog and digital compute works. Pretty simple, right? This method also helps to eliminate a major limitation of using analog compute alone. Since the value is being converted from digital to analog and then back to digital after computation, the data is not distorted after multiple iterations, which was the case with analog compute. This methodology is the backbone of a major current advancement. A major breakthrough has been achieved by the US-based Mythic AI in this methodology of using a combination of analog and digital compute. The US-based company is focused on developing cutting-edge analog matrix processors based on a unique analog compute in memory. In simple words, this company is basically using the solution that is discussed in this video. Let us take a look at the product offered by this company. Mythic AI has developed this little chip with a combination of digital and analog compute as described in the earlier model. This chip can perform trillions of math operations per second, while only consuming about 3 to 5 watts of electricity, as against a dedicated GPU that consumes somewhere around 200 to 300 watts of electricity. This not only makes the processing of information much quicker for edge AI, but also highly power efficient. As a result, this chip can be used for multiple applications. Some of these applications include drones, security cameras, and possibly self-driving cars. This chip also finds use in the realm of AR and VR, where it is able to convert a real-life human figure into a VR form very quickly and efficiently while consuming a fraction of the power of a dedicated GPU, the technology that was conventionally used to perform this job. Analog compute was long forgotten after the advent of digital compute, but in the given scenario where AI is rapidly evolving, I think it would be best to conclude this presentation with the following statement. While digital compute reaches its limits, AI is only getting started. It is pretty much evident at the end of this presentation that digital compute has its own limitations when it comes to training a large AI model, and the analog compute alone is pretty much useless for most modern tasks, but a combination of the two can result into a future that is highly beneficial for edge AI based devices. With this, I come to the end of my presentation. If you made it to the end of this video, thanks a lot for watching. I hope you liked this video. Do not forget to check out my LinkedIn post on the topic Analog Compute for Edge AI. Also, if you found this video helpful, do hit the like button. Also, share it with your friends. I hope this video helped you gain a new insight on the modern world of Edge AI. Thank you for watching.